Right, Sunat?
Yeah.
Yeah. Now, can we say that hypotenuse square, that means AC square, is equals to AB square plus BC square? Can we say?
Yeah, that's a quadratic
Yeah.
formula, right?
It is Pythagoras theorem.
Sorry, wrong term. My bad.
Yeah. Yes, I understand. You already know the theorem. So, this is the Pythagoras theorem we are writing it. Now, can we say let's divide both sides by AC square?
Could you repeat that?
Why we are doing so? Because when we are having an equation, we can do whatever we want. Just we have to be careful that if we are adding a number on the right side, we have to add a same number on the left side. Why? So that equality sign will be valid. If we are having, let's say you are having x equals to y, okay, a condition you are having. So if you are writing plus 2 here, plus 2 here, that means you are not changing anything. If you are writing x plus 2 is equals to y plus 2, still you are maintaining the equality sign. Getting it?
Yeah, I got it.
Okay, so similarly we can do the subtraction of same number on the both sides. Similarly, we can do the multiplication of same number on both sides, and we can also do division of same number on both sides. That is completely allowed. So hence, to prove here the first identity, we are going to divide both sides by AC square. Because the first identity is sin square A plus cos square A is equals to 1. This is the first identity. So we can see there is a 1 on the other side. To make that 1 from this Pythagoras theorem, what we are going to do, divide both sides by AC square. Am I making sense, Zunat?
Yeah.
Okay, so we will be having AC square by AC square is equals to AB square by AC square plus BC square by AC square. Right?
Yeah.
Here we will be having 1 is equals to AB by AC. Okay, AB by AC. Now we are trying to make the identity sine square cos square. So with the help of this right angle triangle, we will see what is sine A and what is cos A. If we are taking sine of angle A, can you tell me just by looking at the triangle what we are going to have? Sine A opposite over hypotenuse, right, Sunat?
Yeah.
Opposite is BC.
VC, hypotenuse is AC.
Exactly. And what is cos A?
Adjacent by hypotenuse, right?
Yes, adjacent by hypotenuse. Adjacent is AB and hypotenuse is AC, right, Sunan?
Yeah.
We will keep this scenario in hand. Now let's get back to our equation. Can we write it as a AB by AC complete square? Can we?
Yes, we can have it.
Yes. And this one BC by AC complete square, right? Now the sine A and cos A, which we have already taken out here, can we put the value BC by AC at the place of BC by AC? Can I write sine A?
Yeah. The place.
So at the place of BC by AC only I am writing sine A. And at the place of AB by AC I am going to write cos A. Is it okay?
Yeah.
And hence, can you see we got the identity cos square a plus sin square a is 1. See, cos square a means what? Cos square. Just a second. See, cos square a means what? Cos square a means cos a's whole square. Okay, what is sin square a? Sin square a means sin a, that's complete square. Okay, so
Okay.
now we can write whatever we have got, we can write it as cos square a plus sin square a, and the other side is 1. So can we write it like this? Just a moment, I'm showing you. Can you see we got the first identity, that is sin square a plus cos square a is equals to 1.
Yeah, we got the first again.
Yes, we got the first identity. Okay, we proved the first identity. Let's summarize the steps. These are the steps. We are having a triangle, a right angle triangle. Okay, where AC square is equals to AB square plus BC square. We have written Pythagoras theorem. Now we are keeping our eye on the identity, and in identity, one of the side is 1. 1. So we are dividing both sides by AC square so that one side at least we will be able to make 1. Once we divided both sides by AC square, we got this step. After that, we are realizing one side successfully we made 1, but what about the other side? We ended up getting the ratio. And later on, we realized that that is nothing but trigonometric ratio cos and sin, and hence we got the identity.
Yeah.
Is it crystal clear, Zunan?
Yeah, I understand it now.
Okay. Now you have to practice it also by yourself. After the class, please do practice by yourself. Now the second one is, the second identity is sec square minus tan square is equals to 1. We will try proving this. Okay. This is what we are going to try to prove. From where? From the identity which we already know. We will be writing, we know that sin square a plus cos square a is 1, right? Right?
Yeah, sounds good.
That we already know. Now, what is the purpose? The purpose is to make sec and tan. Sec and tan. So, sin is there. If we will divide both sides by cos, we will be getting tan. If we will divide here by cos square, we will be getting tan. Yes or no?
Yeah.
So basically we are trying to create tan. Okay. So what we will do here now, this time we will be dividing both sides by cos square. I am going to write dividing both sides by cos square. Sin square by cos square plus cos square by cos square, that is 1, is equals to 1 by cos square. Okay, this is what we are having. Any confusion so far?
No confusion so far.
Okay, now this one we can write sin a by cos a complete square. This one we can write 1, and this one we can write 1 by cos a, that's complete square. Now sin by cos is what, Sunak?
Sin by cos is tan.
Sin by cos is tan. So
Tan.
tan a, that's complete square, is plus 1 is equals to 1 by cos is what?
1 by cos is it sec? No.
1 by cos is sec A, yes or no? Now tan A is square means tan is square A. It's the same thing. Tan is square A means tan A is complete square. It's a same thing. Okay. Plus 1 is equals to sec square. Any confusion so far, Junaid?
No confusion so far.
Now this tan square A we can shift to another side and we will be having sec square A minus tan square A is equals to 1. That's what we wanted to prove. Right, Sunil? This
Yeah,
is what we want to prove. Sec square A minus tan square A is equals to 1. Let's summarize everything. This is the second identity. The first identity is sin square A plus cos square A is 1. Second identity sec square A minus tan square A is 1. See how we prove. We have taken the help of first identity. We divided both sides by cos square. Why? Because we wanted to make tan. Okay. And then we proceeded, continued, and we ended up having. Got it?
yeah.
Now the third identity is cosec square A minus cot square A is equals to 1. Here also we will take the help of first identity, that is sin square A plus cos square A is equals to 1. We will take the help of this identity. Now this time we want to make cosec and this time we want to make cot. So you focus on cot and you tell me how can we make cot over here. Can you tell me, Zunaid? If we will divide both sides by this cos, I want to make cot by dividing.
Right, both.
Did you see? Dividing both sides by this cos is there, sin is there, but we will focus on making cot. To make cot, we need to divide cos by sin. Yes or no?
Yeah, we divide cos by sine.
Exactly. This time we will be dividing by sin square A, and you will find that automatically we are getting sin square A by sin square A plus cos square A by sin square A is equals to 1 by sin square A. Now let's make sin square by sin square 1 plus cos square by sin square can be write directly as a cot square now.
Yeah, we divide directly as possible.
And 1 by sin square is what, Sunat?
1 by sine square is cosine. It's cosine.
Cosec square. Now from here, what are we getting? Cosec square minus cot square is equals to 1. Yes or no?
Yeah, we just
Can you see we got the identity? That
yeah,
is
we
cosec
just
square minus cot square is 1. Can you see? Now let me summarize everything. Let me summarize. These are the three identities we are having. The first identity is sin square A plus cos square A is 1 zone, and keep in mind here angle has to be seen. we can only say that sine square A plus cos square A is 1. Okay, we cannot say that sine square A plus cos square B, that is 1. We cannot say. Both the angle has to be same. If with sine, if it is A, with cos also, it has to be A only as an angle. Otherwise, both has to be B only. Then only the result will be 1. Otherwise, the result will not be 1. Are you getting my point?
Yeah, yeah, I get it now. I
The
was going to ask about what happens if they both would be, but thanks for answering in advance. Thanks for answering.
both the angle has to be same, whatever be the angle, whatever be the angle, be it A, be it B, be it X, be it Y, be it A plus B. If you are having sine square, angle is this time A plus B. Now you are having cos square, angle is this time E minus B. Please don't say that it is 1. If someone is saying to you it is 1, that is completely incorrect. This angle and this angle has to be exactly same. If that is A plus B, this is A plus B. Or maybe both are A minus B. Then only we can use the identity and we can say the result will be 1. Getting me?
Yeah, I got it.
Similarly, for the other identities also, there is only one condition which we have to be specific about, and that is the angle. In this identity, angle has to be same. For sec and tan, angle has to be same. Whatever is sitting with this trigonometric ratio, Zunad, we call it angle. It will always reflect the angle. Okay, so this angle has to be same. That is the only thing which we have to careful with in all the identities. So these are the 3 identities. Now can you tell me quickly what is the first identity, what is the second, and what is the third identity?
The first identity is sin squared plus cos squared equal 1.
Mhm. Next is
The next one is sec squared, uh, yeah, minus tan
minus.
squared, minus tan squared equals 1.
Perfect. Next is
Cosec squared minus cot squared equal 1.
perfect, Sunil. Perfect. Okay, these are the 3 identities we are having. On the basis of, by using these 3 identities, we will be solving questions in our actual class. Okay. Now
Uh,
this one is crystal clear.
yeah, I understand this.
Now apart from this one, any other concept where you, like when I have discussed in class, it is not that clear?
I can't recall any right now. If I can't recall any.
Okay, so if I will ask you, Zunad, what is the trigonometric ratio? You told me that you have already learned the values. Can you tell me quickly the values?
Yeah, the first one is 0%. 0. Second one is 1.2.
1 by 2, no?
1 by 2, my bad, 1 by 2. So
Hmm.
the third one is 1 by root 2. 1 by root 2.
Perfect. Next
Root
one.
3 by 2. Root 3 by 2.
Great.
And then
Next.
1. 1.
Perfect. What about cos?
Cos is 1. Root 3 by 2. 1 by root 2.
Mhm.
1 by 2. And then 0.
So now you understand how to do the simplification which I was discussing in class,
Yeah,
the
it's the
fraction by
opposite.
fraction. Yeah,
Yeah.
yes. So you understand that, right?
Yeah, the inner
Okay.
number is multiplying 100.
Okay, if I will give you one question randomly, not from our syllabus. Randomly, I am giving you 1 by x plus 1 by y by 5 by x plus 5 plus 7 by y. Can you tell me the result, Zonat? Take your time, do it, and let me know what are you getting.
Yeah, I'll do it right now.
Let's do it.
I'm not sure if I got the correct answer.
Please
I
tell
got
me now.
I got 14 brackets 2xy then divided by xy. I'm not sure if that's correct though.
Let me help you with this one. Let me explain how exactly we have to do this. So denominator x, we will focus completely on this part. Okay, we are going to do it first this part. So denominator is x, denominator is y. We will be finding the LCM of the denominator. Can you tell me what is the LCM of x and y?
LCM of x and y is xy. It's xy.
Xy. And what will be there in the numerator? So
It'll be 1y. The first one will be 1y.
1y just y or 1x just x, right?
Yeah, yeah.
Similarly, in the perfect. Similarly, this separately we will be doing it in the denominator. Again, LCM is xy. There we are getting 1y, 1x. Here we will be getting 5y and 7x, right?
Yes, that's right.
Now we are done. Okay, let me show you. Now we can do the. We are having numerator x plus y. Here we are having 5y plus 7x. Here we are having xy. Here we are having xy. Now what we can do, the outer number we can multiply together. Outer number we can multiply together and inner number we can multiply together. So if you are having fraction by fraction, whatever is sitting at the extreme end, on the upper side, extreme upper and the extreme lower, you can multiply both of them. Okay, so we will be having y plus x into x. Extreme outer numbers, outer terms, we are multiplying them and writing it in the numerators part. And the inside terms we will multiply together. Inner side terms we will multiply and will write it like this. Is it making sense to you, Zunat?
Yeah, got it.
Okay, this is the short trick. This is the short trick. However, the long way method is, the longer method is, and let me write over here, the longer method or the actual concept is, if you are having y by x, by xy, whatever you are having in the, after this, whatever you are having, you can write that with the division sign. And you can write whatever is there in the denominator. If your denominator is also a fraction, write it with the division sign. And this is how we can write it. Now there is a rule in fraction chapter which says that we can convert this division sign in multiplication sign. But at the same time, we have to take the reciprocal of very next fraction. So this 5y plus 7x by xy, this one exact reciprocal we will be taking. That means numerator will become denominator, denominator will become numerator. Why we are doing so? Because we converted this division sign to multiplication sign. So at the same time, we have to reverse this fraction. So it will become this. Now with the first fraction will remain as it is. Okay, the first fraction will remain as it is. Now we can see if anything is cancelable, we can cancel them out and we will write our final answer as a y plus x or x plus y in the numerator by 5y plus 7x. Is it clear, Junai?
Yeah, 9. That's one.
This is the longer method, actual method. And what I am telling you, let me make it clear. The outer number, multiply them together, write it in the numerator, and the inner number, multiply them and write it in the denominator. After getting it, whatever cancellation is possible, do it, and you will be getting your answer. Getting it, Zonal?
Yeah, I got it now.
Okay, let me give you the same with the actual number. If you are having 5 by 8 by 7 by 6, here also we are having 5 by 8 by 7 by 6. The short trick says that multiply the outer number and write it in the numerators, and multiply the inner numbers and write it in the denominators form. And then check whatever cancellation is possible, do that and write your final answer. So 2, 3 times 6, 2, 4 times 8, 15 by 28. This is our final answer. That is short trick. And the actual method says that 5 by 8 is divided with 7 by 6, if you understand. And this division sign we can convert to multiplication sign, but at the same time we have to take the reciprocal of the very next fraction, and then only we are allowed to do the cancellation if possible. 2, 3 times 6, 2, 4 times 6. 15 by 28 is the answer. This is the actual way, and that is the short trick. Getting it, Hanyan?
Yeah,
Now the next thing is, what if we are having 5 by 8 by 3? Then how we will use the short trick? What if we will be having 5 by 8 by 3? So here the
we
actual
can add,
methods. Yeah, what?
we can add a 1, yeah, for 5 by
Yeah,
1.
yes, we can write 5 by 1, or we can write like this: 5 divided by 8 by 3. We will be taking the reciprocal multiplication sign, and this one 5 by 1 or 5, whatever you write. With the other way, yes, you have to write 5 by 1 by 8 by 3 and then only outer will multiply, inner will multiply. Getting it, Zuna?
Yeah.
Okay. So if we are having, let's do one question together. 1 by root 2 plus 3 by 2 by 5 by 5 root 3 by 2 plus 1 by root 2. Let's do it together. Okay.
Okay.
First, we will be focusing on this one. We will do it over here. LCM is
LCM is 1 by root 2 plus 3 by 2.
over here. You have, if we will try finding the LCM now. 2 means, do you understand? 2 means root 2 into root 2. Do you understand 2 means root 2 into root 2?
Yeah, 2 is root into root 2. Can we cut root 2?
So in our mind, it is completely going on. 2 means root 2 into root 2. Now LCM of this root 2 into root 2 and root 2 will be root 2 into root 2. Right, Junior?
Yeah.
That means 2 can we write as a LCM, or maybe we can write LCM like this, right?
Yeah.
What will be there in the numerator? Root 2, right? 1 root 2. What will be there in the numerator? The other part, root 2 into root 2. We are thinking 2. We are thinking as a root 2 into root 2. Okay. So it's exactly same. It will be right. Any confusions in mind? Any confusions in mind?
How did you get root 2 on the top again? Can you explain that part? How did 1 become
Because
2?
here root 2 is there and the LCM is 2 times the same thing. So 1 is missing, right?
Yeah.
That you will multiply with 1, right?
Oh, okay. I got it now. Multiply 1. So that's why root 2 is there.
Now we will do the similarly. We will do the denominator. 2 means in our mind it is going on. That 2 means root 2 into root 2. We are thinking 2 like this. Okay. Hence we will take the LCM root 2 into root 2. If anywhere in your book LCM will be written as only 2, please don't get confused. Okay. Now, can you tell me what will be the numerators we have?
The 5 by root 3 and then root 2 plus root 2.
Multiply
Oh,
plus
my bad.
root 2. Wait. 5 root 3 plus root 2. You said it correctly. 5 root 3 plus root 2. Because whatever denominator is here, exactly same we are having. So we don't have to change, right? The numerator.
Yeah.
Right, Sunu?
Yeah.
Okay. 5 root 3 as it is, we will copy paste because the denominator is as it is. 2 means root 2 into root 2, and that is only we are having as a LCM. Getting it?
Yeah. Got it.
Okay, now we will use our concept. Outer number multiplied together, inner number multiplied together. We will keep everything in bracket for clarity. Okay. This root 2 into root 2, if you want, you can write it as a only 2. If you want, you can write it as a only 2. This one. And this one also, you can write it as a only 2, but the numerator we cannot change. Okay.
Okay.
So basically, we can write it as a root 2 plus 3 by only 2 also we can write. That's what I'm telling you. Okay. By 5 root 3 plus root 2 by only 2 we can write. Now outer will multiply together and will sit in the numerator's part. And inner will multiply together and will sit in the denominator's part. We will not multiply, we will check if any cancellation is possible, and here it is possible. So our answer is root 2 plus 3 by 5 root 3 plus root 3. Right, Sunil?
Yeah.
Any confusion? Check it. We understand 2 means root 2 into root 2. And hence we proceeded. How we find the LCM? We take the common factor and then we take the extras. When you have to find the LCM of 4 and 12, 4 means 2 into 2. 12 means 2 into 2 into 3. LCM will be first the common factor. First the common factor. And then the extras. And that is the LCM. What will be the LCM of 2 and root 2? So 2 means root 2 into root 2. Root 2 means only root 2. LCM means common and then extras. Getting it?
Yeah.
LCM is just 2. Getting it? Is it crystal clear, Junaid?
Yeah, I understand this now.
Okay. Let me summarize again. 1 by root 2 plus 3 by root 2. LCM is only 2. LCM is root 2 into root 2. Root 2 into root 2, which can be written as only 2. So if you want, you write it root 2 into root 2 if you understand this 2. Or if you understand by writing only 2, write it that way. But when you are writing only 2, you have to be specific that one root 2 is there, one is missing. So that you need to multiply in the numerator. If you are writing only 2, you have to be careful with the numerator. Otherwise, write the LCM as a root 2 into root 2. You will never ever do mistake. You will understand one root 2 is there and here 2 times is there. So 1 definitely will come in the numerator. And what about for the other? 2 means root 2 into root 2. So other is exactly same. So only 3 will be there. Is it making sense, Sunal?
Yeah, I got it.
Crystal clear?